Hi there, we've got exercise 19A for A-level maths, year 13. Now we're going to look at vectors, and we've got lots to get through, so I'm going to speed on through. And for that reason, I'm going to give you the job of finding these answers. You've got a few things to do. For basic vector work, this should be okay. Draw a picture for this, and you should find that's relatively straightforward. I've gone through that, and that works. Magnitude and direction, you should remember that you need to use Pythagoras to find the magnitude of a vector, and a bit of trig, it says trig on it, to find the direction. Now there's two ways to write the direction. I think the answer you get on this one, it kind of goes this way. It'd be dead easy to find that angle. The answer they give in the answers is that angle, the angle to the positive horizontal. So find alpha and then find theta. And here you've got to think of the distance travelled, or the displacement made. So on this journey, I think it goes from there to there, then it goes back again, and then an extra 120. So work out the average velocity and the average speed, and try to use your knowledge of what speed and velocity actually is. If you can't do any of those, ask me in class. And here are the answers, just so that you have them, so that you'll know whether or not you need to come and speak to me in class. Okay, bear that in mind, because a few things to note. If you ever ask for the displacement, the velocity, or the acceleration on questions which are obviously in two dimensions, like they're written in vectors effectively, try to give your answers in vectors for these three things. But if you ask for the distance, the speed, these are scalar quantities, so that we've already seen in that example of the starter, the speed was asked for and the velocity was asked for. This will be a number. This will be 4.7, 9.2, whereas this will be a vector. It will be 2, 3, something like that. So be aware of this difference between distance and speed and displacement and velocity. First question, I should point out that these are position vectors of the points A, B and C, which are down here, measured in meters, and it wants the average velocity. It also says it takes 5 seconds to go from A to C and 3 seconds to go from C to B. And it says find the average velocity and the average speed from C to B. Well, first of all, C to B, you always do B minus C, so I reckon that's 1 minus 2, I reckon that's 3, 5 minus, I reckon that's 4. And if you look at the picture, it does go 3 across 4 up, so that works. So bearing that in mind, if I want the average velocity then for CB is, well, it's distance divided by time, or in this case displacement divided by time. So it's 3, 4 as a vector divided by how many seconds? It said 3 seconds. So that's quite simply 1, and just do it as a decimal, I suppose, 1.33. That's the average velocity. If you ever want the average speed, well, you're going to have to use Pythagoras, that we talked about in the starter. I'm going to do the square root of 1 squared plus that 1.33 squared, 4/3, I suppose, if I'm doing it precisely. And if you do that, it's 1 squared plus 4/3 squared is 16 divided by 9. 25 over 9, which when I square root is 5/3. This is 5/3, or I suppose 1.67 meters per second. So notice the difference. Already on part A, I've had to find average velocity and average speed. B, find the final displacement of the particle from A. Well, that's ended up there, so that simply wants me to find AB. From A to B is B minus A, so that's 2 to the left, 5, that's 6 up. And again, you can probably look at the picture and it says that. So if that is the answer actually. Final displacement is minus 2.6 meters. The average velocity for the whole journey, this is part C, again this is average velocity for the whole journey, that's from A to B effectively. I know it didn't go from A to B, it did it in 2 parts, but the average velocity doesn't care about that, it just says it's ended up from A, it got to B. So that's the minus 2.6, and it took 8 seconds to do that, so divide by 8 is minus 0.25, it's a quarter, minus a quarter, and 6 divided by 8 is 0.75. And what does D say? The average speed. Oh, now, if you're not careful here, you could possibly use this thing. But in actual fact, it's travelled a distance to there, and it then travels a distance to there. And that total distance divided by the time is what I want to do. I don't use this. So I first of all, the first section of my journey, how far does it go across? It goes 1, 2, 3, 4, 5, and then 2 up. Oh, you said it up there, I suppose. No, it doesn't. So I would have had to have worked it out. But for the first section then, part 1, I'm saying it's the square root of 5 squared plus 2 squared, which sounds to me like 25, root 29. And then for the second part of the journey, it goes 3 across, 4 up. And we should know that 3 squared plus 4 squared is 5 squared, so this is just 5 when you do it. So the total distance travelled is root 29 plus 5, which is 10.38. 39, and I divide that by the 8 seconds for the journey, and I get 1.30 meters. So when I find the velocity, so this is distance over time effectively, it's 1.30 meters per second. Well, I'm pleased about that. It was 1.3. They gave it to 1 dp, but other than that, everything else looks good. The particle moves in a plane. It passes through point A, velocity. So I'm going to write this. V equals 3 minus 2. And passes through point B 4 seconds later. So I'm going to call that one V1. And V2, the second velocity, is 2, 5. Find the magnitude and direction of the average acceleration. That's what he wants. Now, to find the average acceleration, you do the change in the speed. So, or perhaps I should have said the change in the velocity. So anyway, the change in the velocity is, I'll do one minus the other. So I'll do 2 minus the 3. So that will be minus 1. And 5 minus the minus 2 is 7. So that's the change in the velocity. So it's minus 1, 7. And I divide by the time it took to do it. And it took 4 seconds to do it. So I reckon that's minus 0.25 and 1.75. That is my average acceleration. But he wants the magnitude of the average acceleration. So I now effectively find the magnitude of it, which is the square root of 0.25 squared plus 1.75 squared. And if you do that on your calculator, you get 1.77 meters per second squared. Now, if you want the direction, again, think of it as a picture. It goes a little bit left and then up. So my average acceleration goes 0.25 left, 1.75 up. I want this angle here. So I'm going to call that alpha. Alpha equals the inverse tan of 1.75 over 0.25. Ignore the minus again. So 1.75 divided by 0.25 is 7. The inverse tan of that is 81.9 degrees, I suppose, to the horizontal, something like this. So let's find out. It says 98.1 from the horizontal. Is that the? I think that's that angle there instead they've given me. Or they've given me from the positive. That's what they've given me, that angle, 98.1. Doesn't say which angle I want to give, so as long as you wrote it down properly, that's fine. So that's right. A particle moves in a plane at a time. The particle is at point P. Its displacement from the origin is given by this position vector. So this position vector is unusual as much as it hasn't got numbers. It says it's following this rule. So if you like, the x value is t plus 2. And my y value for it is 1 minus t. And I'm doing that because I notice it says find the Cartesian equation. So this is almost like parametric equations. You might remember doing parametric equations. So parametric equations, you very often want the Cartesian equation. You get it by just writing this as t equals, swap those round, I reckon I get x minus 2. Yeah, that's right. And that really just moves over there, hasn't it? And so I sub that into the second equation, I get 1 minus x minus 2 squared. Y equals 1 minus x squared minus 4x plus 4. So what's that? That's, well, minus x squared plus 4x. It looks like minus 3 to me. That's what I think the equation is. You can chuck that into your calculator, and according to me, that's what it looks like. Interestingly, it starts at 2, 1. Why does it start at 2, 1? Well, it starts at the origin RSE, and that means x equals 0, is it? No, it starts at t0. T equals 0. And so therefore, it gives me an initial point of 2. And if I put 0 into this, comma 1, I see. That's why they've drawn it from 2, 1. Otherwise, it would have probably, gone. It had to cross down here, didn't it? It would have gone down here somewhere. Okay, next question, the last question. Whether or not I'll finish on that, I don't know. Two particles, A and B, move in a plane. A starts from the origin with constant velocity, v1 equals this. So if I want to find the constant velocity, the position vector, of A in terms of t, which is what it wants, position vector usually use the s equals ut plus a half at squared formula. But just to be aware, it says it's got constant velocity. Constant velocity means that A equals 0. So effectively all of that disappears, and I've just got s equals ut. So the position vector of A, which might be best written as OA, but really I'm thinking of this as S. And what is S? It's ut. So my initial velocity is that 3 minus 2 times by the t, which I don't know what it is. That's why it says in terms of t. And now normally I'd write plus all this, but there's nothing there to add, so I think the answer is just 3 and minus 2t. There you go. Particle B starts from this position vector and moves with a constant velocity there. Okay, so its position vector for this one, I've got to take into account the fact that it starts here. So if I wanted the position vector of B, OB, that would be, again, think of it as an s equals ut thing. I'd write, that's its velocity. I'd write 1, 3 times by t. That's how far it's moved. But it started at 1 minus 5. That's what this says. So I suppose it's best to write that as t plus 1 and 3t minus 5. Okay. So I've got my two vectors. I'm going to write that as A equals 3 minus 2. Oh, that was 3t. I nearly made a mistake there. And B equals this one. T plus 1, 3t minus 5. And it says, prove that these two things never meet. Well, they will meet if the times agree. So you notice I've got a position vector for this, 3t minus 2t, t plus 1 and this. So when 3t equals t plus 1, it will give me a time. So that gives me 2t equals 1, or t equals a half. So the top line gives me they'll meet after half a second. What's the bottom line give me? The y direction minus 2t equals 3t minus 5. They switch places. I think that gives me t equals 5 seconds. So these are what you describe as inconsistent. And therefore, they never meet. Now I don't think, I'm just looking at, I've got about 30 seconds. I don't think I'm going to do this because I haven't got the time to do it. Perhaps we'll do this in class. Perhaps we'll also look at that starter that we talked about but never actually showed you how to do. But what I want us to make sure, well, let's look at the answers first before I go on. Yes, so I've got these right. They've done the same as me, A and B, and they never meet because they're inconsistent answers. Now that's apparently the distance they're apart. You might want to think about that. But in class we're going to look at exercise 19A, page 429. We'll do as many of these questions as we can, and we'll fill any gaps that we've got, because I think that was quite a tough little lesson. So Thank you very much.